Hi ladies, this is lesson 4.2. In the last lesson we talked about the triangle sum conjecture that told us that all the angles of the triangle add up to 180 degrees. Now we're going to look specifically at isosceles triangles. So we're going to look at the relationship between base angles of isosceles triangle and comparing isosceles triangles to equilateral triangles. So we've got a few vocab terms here, so we're going to define those. On your note sheet, it will help to look at the diagram of the triangle in order to define these definitions. So here's what your note sheet should look like. It says the legs, and you should have this diagram here. So I'm going to use a highlighter to kind of identify some of these. So the first one is the legs. So these two sides, those are your legs. So in an isosceles triangle, you have two legs, and those two legs are congruent. So our legs, we're going to define our legs, and this is all about isosceles triangle. So the legs are the congruent sides. The vertex angle is this angle here that connects those two legs. So the vertex angle is the angle that connects the two congruent sides of the triangle. Or the legs. All right, the next term is our base. And the base is a side of the triangle. It's the side opposite of the vertex angle. All right, and then the triangle, an isosceles triangle, has two base angles. So here's one base angle, and here's the other base angle. And these base angles are the angles that connect the sides, or the legs, to the base. And then lastly, a term that is not in this diagram, but biconditional. And we've worked with this a little bit at the beginning of the year, but we're going to revisit it because this lesson does have a biconditional statement. So a biconditional statement is often written as an if and only if. So remember at the beginning of the year we wrote IFF, that means if and only if. So it's a statement that includes both the conditional statement and its converse. So it's true, it's a statement that's true both ways. Okay, so the first conjecture we have in this lesson is the isosceles triangle conjecture. So it says if a triangle is isosceles, then the base angles are congruent. So if a triangle is isosceles meaning it has two congruent sides, so you have to know the definition of isosceles here. Then the base angles are congruent. Now on your note sheet, there's a question and it says, is the converse true? Well, first let's look at the converse. The converse of the isosceles triangle conjecture. So before we determine whether or not the converse of the statement is true, let's actually write the converse. So on your note sheet, it says if a triangle has two congruent sides, that is a typo. It should say, and please make this correction on your note sheet, it should say if a triangle has two congruent angles, then what do we know about the triangle? So the converse statement switches the if and the then. So if a triangle has two congruent angles, then the triangle is isosceles. So in this case, the converse and the converse of the isosceles triangle conjecture and the isosceles triangle conjecture, these are both true. So is the converse true? Yes. That means that this is a biconditional statement. So this says that both the conjecture and the converse of the conjecture are both true. So it is biconditional. All right, then we have one more conjecture, and it's the equilateral equiangular triangle. So if it's the converse and the condition are true for isosceles triangles, and equilateral triangles are three congruent sides, then the same is going to hold true, that if it has three congruent sides, every equilateral triangle is going to have three congruent angles. In other words, it's equiangular. So we define equiangular as three congruent angles in a triangle. So if every equilateral triangle is equiangular, and conversely every equiangular triangle is equilateral. So if you look at this extra example that you see on your note sheet, it's talking about perimeter. Perimeter is the sum of all the sides. So looking at this triangle, if we want to define the perimeter, or if we want to write an equation for the perimeter, we know that it's 53. And we know this side is x, this side is x plus 5, and this side is congruent to QS. So this also has to be x. So here's how we can write our equation for perimeter. And if we simplify that, we got 53 equals x plus x plus x, which is 3x plus 5. So if we subtract 5 from both sides, we get 48 equals 3x, and x equals 16. So if we're looking for QR, QR equals x, which equals 16. And then looking for SR, we know that SR equals x plus 5 and x equals 16. So x plus 5 is equal to 16 plus 5, which equals 21. So QR is 16, SR is 21. Now looking for angle R, since we know that QS and QR are congruent, those are our legs. So then angle S and angle R, those are our base angles. And in an isosceles triangle, which we have an isosceles triangle because these two sides are congruent, then we also know that base angles are congruent. So the total sum of the triangle has to add up to 180 degrees. So angle Q plus angle R plus angle S equals 180 degrees. We know that angle Q is 90. So 90 plus angle R plus angle S is 180. And we also know that R is equal to angle S. So that's like saying 90 plus angle R plus angle R equals 180 degrees, or 90 plus 2R equals 180 degrees. So 2R equals 90 because 180 minus 90 is 90. So angle R has to equal 45 degrees. So QR is 16, SR is 21, and angle R is 45. So looking at this last closing question, it says find the measures of the three angles in ABC using two different methods. So the first, let's just start with, there's two different ways you can do this. One I think is simpler than the other, but we'll look at both ways. So first let's look at all the degrees, 2x plus 20, 2x plus 20, 2x plus 20. Each of those angles, A, B, and C, are each 2x plus 20. That means that they're all the same. So since angle A, angle B, and angle C are all the same, this is an equiangular triangle. So if they're all the same and the sum of the angles add up to 180 degrees, we can simply say that 180 divided by 3 equals angle A, which is the same as angle B, which is the same as angle C. So that equals 60. So 60 degrees here, 60 here, 60 here. Now the other way you could do it is, I think, a little more complicated, but if you didn't realize that these were all the same, this is how you would have to do it. You could add up all of these angles. So angle A plus angle B plus angle C. And say that that equals 180 degrees. And then you could solve for x. And you should get x equals 20. So then you can substitute that in to find one of the angle measures. So 2 times 20 plus 20 is 40 plus 20, which is 60. So that tells you that one angle is 60, and you could do that for all three angles, 60, 60, and 60. All right, please jot down any questions you have, and we can discuss them in class next time I see you. Thanks.